basically works like this.
Is 2 and a half?
2 to what power gets you 6?
I am estimating 2 and a half.
You're estimating 2.5. Now, what happens here is that we needed a way to solve this type of problem. So what happens is we did solve that problem back in that first unit when we were dealing with sequences in series. Okay, I'm not bothering with it. What happens here? What happens here is that we can use what are called logarithms. These logarithms work with bases and with exponents to solve these types of problems. Right now, this is written into what we would call an exponent form. 2 is the base. That's my exponent. Do you agree on that?
Yes.
In order for us to solve this, we need to get this exponent out of the exponent.
So you take the exponent.
We take the log of that. So what happens here, this is,
The x.
we did that because we had like one problem we had to use logs for before. Oops. We would do this. We would say it's the log base 2 of that. Because we wanted those numbers to be identical. Remember that?
Yes.
That inverted it, it undid it, it got x to equal the log base 2 of 6. And when we talked about that in that first unit, we were solving for this, I think it was like a series problem, wasn't it?
I thought it was an equation that we did.
And that's what it was. And the logarithms allow you to do that. Logarithms and exponents go hand in hand. And it gets us to working with this. And this is where we're going into today. Logarithms of base b. And basically these two parts here. Log base b of y is x. What that means is b to the x equals y. Those two statements are equivalent. One is written as a logarithm, the other is written as an exponent. So we have two forms here. We have what's called logarithmic form and exponential form. They go back and forth with each other all the time. Log base b of y is x. B to the x is y. What we're going to start out with today is not so much just solving for x like we did with that 2 to what power is 6, is we're going to work with a bunch of the little properties of how you switch in between exponential, logarithmic form. We're going to simplify some of them by hand, because obviously there's a button on your calculator that does all this, but we're going to do a lot of this by hand, because it's just exponents and going through. Excuse me. So like I said, this is your logarithmic form. This thing is just all sorts of messed up today. Logarithm form, this is exponential. Is it rhythmic?
There's no y.
Rid? Oh yeah, there it is. Logarithmic. Like arithmetic. Oh, yeah,
Instead of the middle.
exactly. This is why spelling doesn't really count. All right? So let me show you some examples of this. Oh, some real fast properties. There's a couple of properties we're going to use a lot of. Log of base 1. Excuse me, log base b of 1. Log base b of 1 is 0. The reason that is what is b to the 0? 1. So you might see a problem like this. Log base 8 of 1. What does that have to equal? 0. Because it's asking you 8 to what power is 1. You think about what that's asking you. 8 to what power is 1?
That makes sense.
B to what power is 1? 0.
Okay.
That's what they're using. You're going between exponential and logarithmic. All right. You guys have worked a lot with exponents. We've done all the squares, the integers. We've done fractional exponents. We've done negative exponents. All this stuff comes back.
So there's going to be like fractional exponents in this?
Yeah, and you'll see how easy it is. They work back and forth. It's pretty easy. Okay. Yes, ma'am.
So in the log b to the 1, is 1 the base or the exponent?
Which 1 the base, or is b the base? Is that what you're asking?
No, would it, like, if you put it back into exponential
Mhm.
form, would 1 be the base or the exponent?
Neither. The solution.
You're gonna lose it when you're.
That's your base, and that's a base. 1 is just the answer.
I'll put it Okay, so it's like if 1 was y, it would be log b to y, whatever. Okay.
Okay. Same idea here. We go to the other one where it's log base v of b is 1. This is how we were able to undo that log problem in sequences and series when we took the log base 2 of 2 to the x. Since those two values are the same, it becomes, if we are able to drop it out, it undoes itself. What this is saying is b to what power is b? Anything to the first power is always itself. That's all this is saying. So this says b to the first is b. Another example in actual log form, if it was log of 8 of 8. See how those two numbers are the same? Those are both bases. This is in log form, and then this would be written as 8 to some power is 8. What is the power that has to go up there? 1. So this has to equal 1. Okay? You're working backwards with exponent rules that you've done in the past. Okay? Now, a couple quick things on your calculator with logs. Obviously, I want to try and get you guys not to use logs, use the log button quite yet. You don't need it. Okay? You won't need the log button today, probably or tomorrow, until we get into some of the actual equations we're going to get decimal equivalencies. Yes, sir?
When's our next assessment?
Not sure yet.
Is it going to be this week?
Probably not. Okay? I'm not exactly sure where we're going to wind up.
Will it be attachment?
No, because we have there's a good solid 3 sections of just straight log stuff and equations and simplifying before we get to even the modeling stuff. So it'll probably be sometime next week, but we'll play it by ear. So yeah, we got these 2 really easy properties. Does that make sense so far? So what I want to do now is rewrite. I'm going to go between log to exponential. I want to get the practice of being able to do that, because the better you get at rewriting them back and forth, the easier this all becomes. Well, let's do these one at a time. So log base 2 of 32 is saying what?
2 to the 5th.
Right. That's exactly right. 2 to the 5th power is 32.
So you like pulling together this one of those things.
Yeah. So
See
you
what
take
I mean?
the base, like
Like
the
if-
middle.
Oh, yeah. I see what you're saying.
Base, yeah.
So you're trying to take the 5.
And it's sort of nice because the 2 goes down a little bit, so it's lower than the 5, so it looks like
It's like
exponent.
osmosis.
You're so proud of yourself for using that too. It's like osmosis.
What is that?
Look, okay,
The cell membrane.
they're diffusing across 32.
And we
Of
don't.
water.
Like, okay, 2, 5.
Water.
You guys are weird.
5 to the 0 is 1. See, I did my little thing, osmosis,
You
it works.
did your thing, and you did your osmosis. That's Exactly right. We're going back and forth. Log, exponential, and we'll eventually go from exponential to log. What's that?
I was gonna say.
Oh, how do you go the other way?
No, I didn't say how. It was like.
Oh, we will. That's why we'll work one way at a time.
That's reversed.
Ah, reverse osmosis.
Tell me.
Log base 10 of 10 is 1.
Wait.
10 to the first is 10.
I don't
It's just
know.
easy to like push them together.
What do you get for this now?
10 to the first is 10.
10 to the first is?
10.
Okay. Real quick, log base 10, where is this coming from? Before we go further.
What do you mean, where is it? Oh, that's the one thing.
10 to the first.
Wouldn't that be 1 to the
No, remember, this is your base, this is your exponent, so it's 10 to the first is 10.
Just 100.
10 to what power is 10? 10 to the first power. Okay. Now, real fast, if you guys look on your calculator, you're going to see that you have a button that says log. Okay, you see there's a button there that says log. Now, if you use just that log button, it's implying that it's in base 10. That's how these calculators were done. So if you just hit the log button, it's base 10. Yes, ma'am? You ran out of batteries? Did they-
Then you hit math, and then you scroll
If
down
you want
to
to,
log
if you want to
base.
figure out to change the base around, these calculators will do a change of base for you by pressing a button. Whereas, you know, we used to have to actually press more than one. So if you hit alpha window, and I believe it's number 5, alpha window, and you select option 5, you see it says log base.
Wow, rad.
The log base is the log base is the log base is the log base.
Or do you need to adjust the log base?
We will. Eventually, we will have to adjust the log base. For like your example where we were solving this equation here, I had to have 6 to what power? Log base 2 of 2 to the x is 6. You had to take log base 2 of 6, where you have to put in those values and it would spit out some funky decimal. Okay. But we will get to that. Yes, ma'am.
Wait, doing out the window, is it the same thing as going down the map?
I think so. Is it in there under math? Yeah, it's the same thing. This is just a shortcut.
Yeah.
So remember, you could type this as a log base 10 if you want. You will see it in your book a lot of times if they only have it written out as. So it says the log of 100. Yes. Very good. This is implying that it's a base 10. They're just not going to write the base. That means it's the same thing as log base 10 of 100. Okay?
That's so mean. I'm never going to do that.
It's very easy. You're going to see, if you don't see a number there, there's a 10. Otherwise, you're going to see something where it's going to say this. All right? Then you have to find decimal. It's a little tricky, yes. All right?
The second time I said like 10 grams.
No. All right?
Then it's like this.
Back to this.
Oh, okay.
Log base 10 of 110.
10 to the negative 1.
Stop.
Very good.
-1.
Very good. Don't use your calculator.
Oh, that's like 110.
Why did you say negative 1? The answer is right there.
Oh, that's right, it is. Duh.
Oh, got it.
I was giving you credit. You should have gone with it. It's okay. Remember, what this is saying is 10 to the negative 1. 10 to the negative 1 is 110.
I don't understand how this works, I'm just gonna accept it.
All you're using is your exponents.
Just weird.
You just gotta.
It's
thinking
new, it's
about it
weird,
too
it's different.
thoroughly. You
Just
gotta
remember.
Just look at me like that works.
I was thinking like
It's
how,
better
like,
than bad than
it's
good.
like how 10 to the negative 1 is what is long even be actually.
It means a chunk of wood larger than a stick, but smaller than a tree.
As long as
That rolls over
I
dog.
get it and test.
It really rolls over your neighbor's dog. It's great for a snack, it fits on your back, it's.
Log,
I
log,
know.
log.
Thank you for listening. I'm sorry, Chloe, what were you saying?
Like what does log actually do?
Logarithms, what logarithms are doing is ways of rewriting exponents.
What is the real life? Okay.
All right? It's a different way of writing out exponents, if you want to think it that way. So log of base 1/2 of 2 is -1. Yes, ma'am?
It's 1/2 to the -1 + 2.
And that should make sense. 1/2 to the -1 is 2. Because you flip it, okay?
Yeah.
You do a lot of level.
Yeah.
Now, what's going to happen here as we keep using these is that they're not going to tell you what the answers are. Oops. You just have to figure it out from that.
How?
How? 1/2 to what power is 2? Things like that. And just like the one where Christian just did this, where I said the log of 100.
That's
10. 2. It's 1. It's 2.
Careful. Just like Christian just answered this question a second ago. Log of 100. What's the base that you don't see?
10.
10. So this is a log base 10. So that means 10 to what power is 100? 2.
Because that's just a thing.
Oh, so think about it.
How did I know what? Guys, please. I'm sorry.
How do you know that it's 10?
How do I know that it's 10? Because if there's no number there, it means it's base 10. That's the rule.
They're getting lazy.
That's all. Yes. If there's no number there, it's base 10. Otherwise, every other one of these, you'll notice has some sort of a base. Sometimes they put a 10 there, sometimes they won't. If you don't see a base value next to the log, that means it's in base 10. That's just the rule.
On C or D, it would have done 10 if that was what it.
Yes. Yep. Yeah, if they wrote it out as the log of 0.01, it's implied that it's a 10, base 10. All right, is that clear?
Yeah.
That's all that is, guys. It's just an implication of the rule. Okay? No? We just did these.
3 squared.
Yeah, we did.
What's the first one?
3
3 to the second is 9.
3 squared is 9. What's the next one?
5 to the first is 5.
5 to the first is 5. Third one.
1/2 to the -2 is 4. 19 to the 0 is 1.
Dude, osmosis is the way to go.
Osmosis is the mostest?
Yes! Can I write that somewhere, please?
Sure.
Yes!
Right
Now what do you do?
Give 9 to the 1/2 equals x. And then you just and
Okay.
you square root it. So 8. Yeah.
So hold on, listen up here. See how the problem says log base 9 of x is 1/2.
So.
What that's asking you is 9 to the half power, what's x?
So that.
3.
Wait, 9 to the 1/2.
I'm kidding.
Because 9 to 1/2 is.
What's the 1/2 power rule again? Remember that? Square root. Okay. That's where these things are going to come back. You're going to see the third roots, square roots, stuff like that, okay? Yes, ma'am?
Actually.
I don't know how you have a class.
No, these are going to go positive. This is going to be positive. Logarithms will go positive, okay?
Well, same as.
I don't know, it's big, it's heavy, it's wood.
Like logic.
Sure.
I like the Civil War one. That's right.
The Civil War one is pretty clever, all right?
That one.
Now, we're going to do these without using the calculator.
3x is 80. 3x is 80.
Remember, what you're asking yourself here is log base 3 of 81, okay? That means 3 to what power is 81?
3 to the 9.
4.
It's like, I know it's more than 3, but it doesn't.
This
Well,
is
you're using some of the rules of exponents you've done in the past, your squares, your cubes, things like that. You should be able to pick out a few of these without too much of a hassle. Now, the next one is a little bit trickier. It's the log base 5 of 4 hundredths. What is that as a fraction?
It's 4 over 100.
It's
4 over
1/25.
1, which is 1, so it's log base 5 of 1/25.
It's 1/4, right? No.
5 to what power is 1?
-5.
Negative 5.
5 to what power is 1/25?
Negative 5.
5 to the negative 5?
No, -2.
Very good.
Oh.
I was thinking like 5
Did I get that
times 5.
Yes,
Oh,
you
wait,
did.
duh.
I win.
Now I see my mistake.
So, does that mean the answer is
Your answer to that is
Or negative.
-2. Very good.
It's just complicated since it's a decimal.
And that's why I want you to, when you see decimals, go to your fractions. Go to your fractions and write out what they mean. Because you guys have worked only really in fractions. You haven't worked in decimals. Decimals are awful. Correct. This is asking you 1/2.
So it's like the square root of it.
1/2 to something is 8. Well, notice you're starting with a fraction, you're ending in an integer, which means you probably have what kind of an exponent? Negative exponent.
Negative 3.
-3, very good. What's 2 cubed?
8.
8. So this is to the -3.
Oh, to flip it.
Correct, and that's the trick here. You start to pick up on the, all right, I started with a fraction of ending in an integer, it means I had to have a negative exponent to flip it. If you start with an integer, you gotta flip it to a fraction, it means you gotta use a negative exponent. So you're using these values back and forth, okay? Very
Wait.
good.
Can I figure this out?
Log base 9 of 3.
9. 1 to something equals 3. 1/2.
Perfect. Are we getting a half?
Yes.
You're using the exponent rules that you probably absolutely love.
Yeah.
Oh, so much.
I so enjoy exponents.
I don't believe you, but that's okay.
It wasn't true.
Okay, so this here, you get 9 to the half power, is 3. You're asking yourself, log base b of y, b to what power gets you? Okay, b to what power is going to get you? That's my reminder to give you something.
Worksheet?
No, I've got this, it's a really nice worksheet that I found that goes along in tandem with kind of like this whole next 3 sections with properties and simplifying and all that.
Is it gonna be
It's
like?
just, these are just, no, it's not homework, these are just ones to keep in your notes. I hole punched it, that way you don't have to keep writing down all the problems. We can just sit there and look at them. These are, I guess you would say, supplemental to some of the stuff that we're working on. What's that?
Apricot is a laceration.
Yeah.
What happened?
So what I want to look at here,
That's your fault.
it also goes, obviously this is not 2.7, I don't know where, I got this from the internet. It has a nice set of tutorials built into it. I sent you- send it over. That has some nice examples through all the stuff that we're going to be looking at over the course of the next few days. What I want you guys to do is take, I don't know, 10 minutes or so. And I want you to do these groups of problems.
1, 2, and 3?
Yeah. Okay? You're rewriting from logarithmic to exponential, exponential to logarithmic, and then I want you to solve. Remember, when you're solving, don't use your calculator. All right?
You just want us to solve to the root of 3?
Yeah, that's going on.
Actually, I didn't finish. But can I teach?
No?
Okay, if you didn't finish, why would you teach?
I only have like 2 rows.
Now, I know that we've done a whole bunch of the going from log form into exponential. Those are usually pretty easy. One of the reasons why I wanted you guys to see these is that you'll notice how they're flip-flopping variables with x's and y's. I didn't want you guys to get pigeonholed with the idea that it's always going to be a y at this spot and x at this spot. Sometimes they move them around, okay? So here, this was just, 4 to the 3rd power is x. You're not solving it, you're just rewriting it, okay?
Yes.
Is there anything in the first 6 that you want to double check, make sure you're okay?
No.
Okay.
Just like all that.
Now going the other way into the log form. This is the one we haven't done yet. I haven't even shown you an example yet, just to see if you can do it.
I get it.
So it's b to the x equals y. So therefore log base b of y is x.
But your base is always 4, and then your solution.
Your base is always your base. That's a good way to think of it. So we have log base 3. Log base 3 of y is 4. You okay with that? No. You got them all wrong? You just flip-flopped it.
Yeah, she put 4
Log base 3
Choose random variable.
of x, oops, log base 3 of 27 is x. I'm sorry, what were you asking? Why were they using random variables?
I use random variable.
Oh, that's fine. That's fine, it's not a big deal. Log base 4 of m is 2. You want me to continue on the log form, we okay?
I think we're great.
Sometimes, like, overnight swag, I'm just throw it away.
On 3 to the 5th? So you have log base 3.
I want you talented.
Log base 3 of y is 5.
I really did.
Okay. All right, let's go to the solves then.
Beam 3, 10, 17, 48, 8. Is it neat set?
Log base 3 of x is 4. 3 to the 4th is x. Very good. We got 81?
Yes.
Right. Log base m of 81 is 4.
3.
It's 3. Log base 3 of 81 is 4. Log base x of 1,000 is 3.
That's 10.
10. Very good.
So now, like, what if they're telling you to solve a problem?
Yeah.
Would they, like, if, I guess they would have given me the answer. I was gonna say since x is 10, would they just,
Sometimes it's written out. Like I said, there are only so many of these that you'll be able to crank out by hand without using a calculator, because they just start to get really messy. The more fun ones. Log base 2 of x over 2 is 5.
X equals
64.
64.
Whoa, okay.
64.
2 to the 5th is x over 2. So 32 times 2 is x.
I thought 32 times 2 was.
Wait.
You
Oh, okay, I get it now.
got it?
I couldn't use a calculator.
So, x is 60.
Log base 3 of y is 5.
3 to the 5th is 223.
Very good. 3 to the 5th is
Because it's just
2.
81 times 3.
Very good. And then lastly, 2 to the 5th power is 4x.
8.
8. You guys all get 8 for that last one?
8.
Did you?
Sure.
I'm just gonna mess
I got 8.
I don't know. Whenever I do the fifth, I don't add one more, so I'm going to do the sixth.
We'll go through that.
I did not get 8.
Okay. So here's where logs start to get a little bit more interesting. It's when you start to work with them in terms of inverses. Now, we've already talked about how the inverse stuff works, how logs undo how you can undo a log. Let me show you exactly what's happening. If you have log base 3 of 3 to the x, if I'm looking at that log has a base of 3, and the exponent has a base of 3. Everybody see that?
Yeah.
Since those two values are equivalent, since these two numbers are the same, they undo each other. They're inverse properties of one another. That's why your answer here is x. The exponent drops. Because, again, this base and this base are the same. That's how you undo these. That's how we did this problem. Log base 2 of x equals 6. We did things like that. We undid it by taking the log base. Same idea going the other direction. If it is 4, it's the log base 4 of x. Right here, that's a base. Raised to a log that has a base of 4.
Hold on.
You can
These-
raise it to a log?
Yep. Those two have the same bases. You see that?
Yeah.
They have the same bases, the exponent falls. Yes, ma'am?
Why?
So,
Why? How do you undo multiplying?
Divide.
How do you undo adding?
Subtract.
How do you undo square rooting?
Square.
So how do you undo log?
I do a square root by square root.
How do you undo a log? You exponentiate it. I think they made that up.
I like that
How
one.
do you undo an exponent? Log.
That makes sense.
They're inverse properties of one another.
Okay.
Let me show you an example, and I guarantee you're going to be okay. Trust me on this. Christian.
So like, so you get rid of the 4s in
Mhm.
that one, and you get rid of the log.
Yeah.
So is it just x equals x?
Yes.
Then how do you know x?
It's just showing how the property works. Because eventually what this is going to be is, it's going to have to equal some number. We have to figure out how we keep a balanced equation, okay? That's what we're getting to. Now, let me show you a couple examples as far as, I'll come back to the natural base. I've got this a little out of order here. Let me show you how this works as far as simplifying. I have 10 to the log of 2. Hold on.
Okay, so wait,
10 to the log of 2.
that means it's 10.
It's base 10.
It's base 10, so this is 10 to the log base 10 of 2.
Wait, does that mean that your 10s cancel off?
It's exactly what happens. These 10s are the same, so what are you left with?
2.
Wait, so what about
If there's no
a
log there,
Now, in the next one, you have log base 3 of 9 to the x. I need to get that 9 into a base 3. How do you do that?
I don't know.
How do you rewrite 9 as base 3? It's 3 squared, isn't it? So this is the same thing as log of base 3 of 3 to the 2x. Are these two the same?
Yeah.
What does it simplify to be then?
2x.
Whoa.
You're simplifying by rewriting in terms of bases and exponents. You want your bases to be identical. Once they become the same, these little properties happen. Things drop out. They simplify through.
I'll figure
What's
it out.
that? I'm not dividing. It's,
Yeah, you did x one.
oh, where is it? If I do this,
Wait, can you not move on? Oh, never mind, you're good.
log base 4 of 16 to the x.
Is 4 to the 4 to the second.
Yes, ma'am. How to get to 3?
2x, right?
Yeah.
I wanted to rewrite 9 in terms of a base 3, because this was a base 3. 9 is 3 squared. So this one is the same idea. It's log base 4 of 4 to the 2x, which gives you 2x. We're working with bases and exponents. We want those to be identical. Oh, we're running a little late. No big deal. Let me give you a few of these to try out for tonight. And we'll continue with this. We left off at like natural log, which is fine.
Oh my gosh, this days went by so fast.
Really?
I feel like math
What's
was
in that lunch seconds like a breeze. So like that was
What'd you say?
Why?
I actually had fun in this one last. I've actually never had a movie in
Do those two sets, please. Sure. We have not talked about natural log yet. We'll start natural log tomorrow, and we'll go natural log, and we'll probably get to some of the graphing tomorrow. Okay? Graphing the logs is where it gets a little bit messier. All right?
Oh, I've always been.